Hello friends, welcome to engineering tutorial. In my previous videos we completed frequency modulation. Well, not completed, but we have discussed various concepts related to frequency modulation, such as generation of a frequency modulated signal, the frequency deviation, modulation index, spectrum of a frequency modulated signal, and representation of a frequency modulated signal in terms of modulation index. So in today's video we will be starting a new category or new type of angle modulation, which is phase modulation. We know that angle modulation is of two types, frequency and phase modulation. So we will discuss today some of the basic concepts related to phase modulation and generation of a phase modulated signal. So let's get started. So what is the definition of phase modulation? Phase modulation actually involves change of the instantaneous phase. Now please pay special attention to this term, instantaneous phase. Okay, the instantaneous phase of a carrier signal with respect or proportional to the modulating message or baseband signal. Okay, so the instantaneous phase of the carrier signal is changed or modulated or altered proportional to the message signal. Now the amplitude and the frequency, they remain constant, they remain unchanged, only the instantaneous phase of the carrier signal is changed. Okay, so as usual we will be taking cosine carrier and message signals. So let the carrier signal be represented as C as a function of t equals to EC cos omega ct plus phi 0, where EC is the carrier signal amplitude, omega c is the angular frequency of the carrier signal, and phi 0 is the initial phase. And the message signal will be represented as Em cos omega mt, where Em is the message signal amplitude, omega subscript m is the message signal angular frequency. Now here in this carrier signal wave, omega ct plus phi o is the phase angle of the unmodulated carrier wave. We know that in phase modulation the instantaneous phase angle is altered. So that is given by the phase angle of the unmodulated carrier wave plus the time varying component, which is proportional to the message signal. So here, generally for the sake of simplicity, we will be taking phi 0 as 0 so that the calculations are simple. This will be discussing in the calculations. So here what is done is that the instantaneous phase is altered by this parameter kp mt, kp into mt. This is what constitutes phase modulation, this extra factor which gets added to this. Okay, this extra factor kp, k subscript p into mt is added to the instantaneous phase angle omega ct phi 0 of the unmodulated carrier wave. This equation here represents phase modulation. This addition of this extra term kp into mt, where kp is the proportionality factor or constant in phase modulation and mt is the message signal, which gets added to this omega ct plus phi 0 unmodulated phase angle part, is what constitutes phase modulation process. So as I said, we take the initial phase as 0. So this part is taken as 0 for the sake of simplicity in calculations. So we get the phase modulated wave as EC cos psi I t, which is given by the phase modulated signal as EC cos omega ct plus kp into mt. This addition of this extra parameter to omega ct, the instantaneous phase angle of the unmodulated carrier wave, which we have seen here, the phase angle of the unmodulated carrier wave, this addition of this extra term, kp into mt to this part omega ct is what is called as phase modulation. The amplitude remains unchanged, the frequency omega c remains unchanged, only the phase, unmodulated phase omega ct plus phi 0 with phi 0 taken as 0 gets changed by omega ct plus kp into mt. This addition of this extra term kp into mt to omega ct is called as phase modulation. So now we will be discussing some concepts related to phase modulation, such as the frequency deviation and the modulation index of a phase modulated signal. Okay, so frequency deviation, as we have discussed it in frequency modulation, it is the maximum departure of the instantaneous frequency from the carrier frequency. That definition is also valid in phase modulation. It is the maximum departure of the instantaneous frequency from the carrier frequency. So now we have to calculate here the instantaneous angular frequency. Now we know that the instantaneous angular frequency is the derivative of the instantaneous phase angle. Now the instantaneous phase angle here, psi I as a function of t, is omega ct plus kp into mt. This part is the instantaneous phase angle. So when we differentiate it with respect to time, we calculate or we get the instantaneous angular frequency. This is the instantaneous phase angle. When we differentiate it with respect to time, we get the instantaneous angular frequency. So here the instantaneous angular frequency omega subscript I is equal to derivative of the instantaneous phase angle with respect to time, which is omega c plus kp into dmt by dt. This is the instantaneous angular frequency. Okay. Now frequency deviation, as I said, it is the maximum departure of the instantaneous angular frequency from the carrier frequency. So here we calculate it as omega c plus kp dmt by dt minus omega c. Omega c gets cancelled out, so we get only kp dmt by dt modulus max. Now we know that the message signal is actually em cos omega mt. So when we substitute message signal with em cos omega mt and differentiate with respect to time, we get minus kp em omega m sin omega mt. The derivative of cos is minus sign, so we get the minus sign here, and em omega m and kp are constants, so they get outside. So when the modulus of this value, which is the maximum value, occurs when sine is equal to 1. The maximum value of sine is equal to 1. So the frequency deviation is equal to kp into em into omega m, which is the product of the proportionality constant in phase modulation into the message signal amplitude into the message signal frequency. Okay, so this is the frequency deviation of a phase modulated signal, which is equal to kp into em into omega m. This is the proportionality constant, this is the message signal amplitude, this is the message signal frequency. Now modulation index, also the definition stays the same as we have in frequency modulation, which is the ratio between the frequency deviation and the message signal frequency. Okay, the modulation index in phase modulation also is the ratio of the frequency deviation and the message signal frequency, which is equal to kp em omega m by omega m, which is equal to kp into em. So the modulation index is equal to kp into em. This is the modulation index for phase modulation. So here we have discussed about frequency deviation and modulation index in phase modulation. Next we will discuss about the principle of change of phase in phase modulation or So how the carrier signal phase changes with respect to the message signal. So what actually happens is that when there is a crest or positive peak point in the modulating or message signal, there is a crest to crest change or a positive peak to positive peak change in the carrier signal, which results in the phase modulated signal. Okay, so whenever there is a crest in the message signal, there is a crest to crest change in the phase modulated signal. Okay, so whenever there is a trough or negative peak point in the message signal, there is a negative peak to negative peak or trough to trough change in the phase modulated signal. Okay, a trough in the message signal, a trough to trough change in the phase modulated signal. So we will see it through the various waveforms that occur in a phase modulation signal. So here we have first cosine wave, which is the message signal. Then we have is the carrier signal. Okay. Then we have here is the phase modulated signal. Here, during the positive peak or crest of the message signal, okay, crest of the message signal, there is a crest to crest change. Okay, crest to crest change in the phase modulated signal. During the trough or the negative peak of the message signal, there is a trough to trough change. Okay, trough to trough change in the phase modulated signal. Again, during the crest of the message signal, there is a crest to crest change in the phase modulated signal. Again, during the trough of the message signal, there is a trough to trough change in the phase modulated signal. Again, it is a crest to crest change. That is the principle of phase change in phase modulation. This is how the phase of the carrier signal changes to give us the phase modulated signal. Whenever there is a crest in the message signal, there is a crest to crest change in the carrier signal, which gives us the phase modulated signal. Whenever there is a trough in the message signal, there is a trough to trough change in the carrier signal, which gives us the phase modulated signal. This is the resultant phase modulated signal, which we get as a result of phase modulation. So here we have discussed some of the basic concepts related to phase modulation, such as how the phase modulated signal gets generated, the frequency deviation, the modulation index. So I hope you like this video. Please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, communication and instrumentation engineering. Have a great day. Thank you very much.